So the next idea that we're going to talk about is the tangential acceleration, which is what you get when you have an object moving along a curved path with changing speed. I've opted to have an object here moving with increasing speed. So you can see my object initially has a small velocity vector, and then it has a larger velocity vector. I have then drawn a picture here that allows me to find dv, the instantaneous change in velocity, which I know from the definition of acceleration should be the direction of the acceleration. Now right away what we see is this direction is no longer perpendicular to the curved path, which is what we saw for the centripetal acceleration for an object moving along a curve at constant speed. And so we need to update our model for the acceleration of an object moving along a path. And what we can do is we can take a vector like this one, which I'm going to draw blown up here. There's my dv vector. Actually, what I'm going to do is draw this as the acceleration vector now, since they point in the same direction. So here's the acceleration vector. And I can break it into two components. A centripetal component that would point perpendicular to the path, which here would be something like this, and a tangential component which points tangent to the curve. And I'll label these AC for centripetal and AT for tangential. And what you can see is this works just like all the other vectors we've broken down into components over the past term. It's just that instead of fixing the two components to an xy coordinate system, we put one in the direction perpendicular to the curve. That's the centripetal acceleration. And then we put another component tangent to the curve. And of course, those things are perpendicular to each other by definition.